All right, so we're going to talk about quadratic models and learning how to use the regression feature in the calculator to come up with the equations that go with these. So first we're going to decide whether each of these sets of data could be better modeled by a linear model, which would be like y equals mx plus b, right? That would be a linear equation. Or if it would be better modeled by a quadratic equation, which would be y equals ax squared plus bx plus c, the q there for quadratic. Or maybe it's not better modeled by either of them, okay? Now, you could plot all of these points by hand and kind of look at the shape of them. Remember, linear means that the data is going to kind of form a line. Quadratic means it's going to kind of be a curved shape. Now, it doesn't have to be the whole U, like it could have just been like half of the U, okay? But I think it's easier, and I want you to get the practice of putting it in the calculator, so that's what we're going to do. So the very first thing that you need to do on your calculator is turn on your diagnostics. So you're going to go to the catalog, which is second and the 0 button, and you're going to go all the way down until you get to diagnostics on. All right, when you get to diagnostics on, you're going to press enter, and then you're going to have to press enter again, and then it should say done. All right, now that we've got that turned on, we can go ahead and do the rest of this. So what we're going to do is we're going to make a table of values based on the points that we had on question number 1, part A. So we're going to go to stat, and if you need to write this down, then do that. Stat's where we go anytime we want to make a table of values. And then we're right here on the edit menu, so we're going to choose edit. Now, if you have stuff in there, let's say I had a 6 and a 3, whatever. If you go up to the list name, like list 1, and press clear, then when you drop down back into the list, it'll go away. Don't press delete, because then it deletes the entire list, like the whole list name and everything. So what we're going to do is we're going to take all of the x values in these points. So the 0.9, the 1.2, 1.3, 1.4, 1.6, 1.8, and we're going to put that in list 1. List 2 is going to be made up of all the y values, so the 1.7, the 2, 1.9, 2.1, 2.5, so on and so forth. We're going to make a whole list of just those values. So x's in the first list, your y values in the second list. Okay, so once you have those in, x is here, y is here, then you need, we want to look at it on a graph just so we can see kind of what it looks like, right? Like, does it look like it's a curve? Does it look like it's a line? You know, we want to see. But sometimes these numbers are not on the graph, if that makes sense. Like if this was a huge number, like 400, we would have to change our window. These are all between 0 and 10, so we don't need to do that. So we're going to go up to the y equals, and we have to tell our calculator that we would like for it to plot those points. So if you have something in here, just clear that out. So you're going to go up to plot 1 and press enter. That way it's highlighted in black. See, when I drop that down, it's highlighted in black. And then I'm going to go to graph, and you should see little points on here. Now sometimes it might be kind of hard to look at them, and maybe you do want to adjust your window. So if I look at my data that I have in my table here, I'm going from like 0 all the way to 4 something, right? So maybe I want to adjust my window. So for my x values, my smallest is 0.9 and my biggest is 4 something. So maybe for my window, I want my x values to not go from -10 to 10. Maybe I want those to go from 0 to 5. So the smallest x value I'll have on my graph would be 0, and the biggest x value I would have would be 5. This number right here just means that you are counting by 1. All right, and then you could do the same thing for your y values. So the smallest y value that you have is, looks like 1.7, so maybe we'll start at 0. And the biggest y value you have is 5, so you kind of want to go a little ahead of that, so I'll go all the way to 6. Oops. And count by ones is fine. Then when you go back to your graph, they're a little bit easier to see, right? So would you say that this would be better suited as a linear equation or quadratic, or neither? Does it look more like a curve, more like a line, or neither of those things? Okay, more like a line, so this would be more like a linear equation. So for part A, this one would be linear. So we are going to repeat the same steps for part B. We're going to put all of our x values in list 1, all of our y values in list 2, and we're going to take a look at that. So we'll go back to stat, and we'll choose edit again. Now you can type over these if you want to, or again, you can pop up, press clear. I kind of like to do that, that way I don't accidentally have extra stuff in there. Okay, and if you notice that the first ones are the same, then don't clear your list. So the third time we won't clear our list for the first list. All right, so then we need to adjust our window, right? Not for the x's, but our y values have changed. So our smallest is, we'll start at 0, but our biggest goes all the way up to 27, so maybe we want to go all the way to 30. So for our window, you can leave your x's the same, but your y values, your maximum y should be 30. That way you can see it on your graph. And count by ones, it doesn't matter. So we'll go to our graph. We've adjusted our window, right? That way we can see all of our points. So this definitely looks like a curve, right? So would that be more linear, more quadratic, or neither? Quadratic. All right, so the second one will be quadratic. And then we're going to repeat the same process for the third set of numbers, but all the x's are the same, so you just have to change the y values. All right, now that we have those in, we need to adjust our window, maybe. We went up to 30 a while ago, so that should cover all of these. All right, so we'll go to our graph, and this is just all over the place, right? I mean, you do have like a curve here that could be quadratic, but you're looking at the whole thing as a whole. So this one would be neither. Nothing is going to create a good curve for us or a straight line. So now we're going to use some data to actually write an equation for what we've been given. So a study was done to compare the speed x in miles per hour with the mileage y in miles per gallon of an automobile. Okay? The results are shown in this table right here. We're going to use a graphing utility to make a scatter plot of this data. So that's the first thing that we're going to do. So we're going to go and we're going to do the same thing. X's are going to go in list 1. Y's are going to go in list 2. So we'll go to stat, edit, and I'm going to go ahead and clear out both of my lists before I do that. Okay, so now we have our data. We're going to have to adjust our window so that it fits with the data that we have here. So we're going to go to our window. Our smallest x value is 15, so I'm going to start at 10. And our biggest x value is 75, so I'm going to go all the way to 80. And we'll count by ones. All right, and then our smallest y value is 22. So let's start at 20. And then our biggest y value is a little over 30, so let's just go to 35. And then let's take a look at it. All right, so although we do have this little dip right here, for the most part, it does make a curve, right? Like a quadratic equation would. So we're going to have it make an equation for us that will fit this data. So I'm going to go back to stat, but this time I'm going to choose calculate because I want it to calculate something for me. Now, if I was doing a linear equation, I would choose the linear regression, but I'm not. I'm doing quadratic, so I'm going to choose option 5. And this is just asking you where your data is located. So your X's are in list 1, so enter. Y's, those are in list 2, enter. So you're going to go all the way down to calculate and press enter. All right, do you see this R2 right here? This is what the diagnostics being turned on gave us. All right, this tells you how good of a fit it is for what you chose. So like we chose quadratic. So the closer this is to 1, the better fit it is. So let's say it was like 0.75. That would not be a good fit, right? And I'm just going to show you, for instance. Let's say that we had chose linear for some reason. Do you see this R2 value? This is not close to 1 at all, right? Which would tell you, hey, this is a really bad fit. Like, you should probably check that out again. So we were good in deciding that this was quadratic, right? Because we want to look at that R2 value, want it to be really close to 1, okay? And sometimes you have to compare, right, and decide which one would be better. So we know quadratic is better. They give you the number that should go in front of your x squared, which is your a value, the number that should go in front of your x, which is your b value, and then that number at the back. So we're going to give it 4 decimal places when we write the equation down. So the equation would be, and I believe this is part B, where it says use the regression feature of the graphing utility to find a model that best fits the data. This would be your model, right? So this is the answer to part B. So your answer would be negative 0.0082, because we're going to give it 4 decimal places, x to the second. Put a y out in front of that. Y equals. All right, then we have a positive b, so plus 0.7468x, and then the c is the number at the back, so plus 13.4622. Now, to make sure that we're not just cray-cray, right, we're going to go ahead and graph this equation in the y equals so we can watch it and see how it fits the data that we have. All right, so go to your y equals, and you're going to put in that equation. So negative 0.0082x squared plus 0.7468x plus 13.4622. And that is a good fit for our data, right? All right. So it says approximate the speed at which the mileage is the greatest. Okay, mileage is represented by the y, right? So you want to know when you're going to have the biggest mileage. So if you look at this, the greatest mileage would be, that's your y value, so that's how high up you go, right? Your maximum. So right here on this graph, that's where you're going to have your greatest mileage, right? The most you could get. You're trying to figure out what x value that is. What is this point on your graph called? It's called your, what's the highest point called? Maximum. That is correct. So you want to find the x value of your maximum. At what speed does this occur? So what you're going to do is you're going to enlist the help of your calculator. You're going to go to the calculate menu, so second trace, and I want it to calculate my maximum, which we've done that before. So option 4. And remember, you want to be on the left side first, because that's what it's asking for. So I'm going to make sure that I'm on the left side of the highest point. press enter, and then it wants you to be on the right side. So go all the way to the right of your maximum, press enter, and then it asks you want me to guess, and the answer to that is yes, so press enter, and then right there, so the highest mileage you're going to get is 30.5, right? And the speed for that would be, let's just round up and say 46 miles per hour. So 46 miles per hour would be the biggest speed you could go and get the best gas mileage. All right, number 3. The table shows the numbers why millions of people ages 16 and older that were not in the U.S. labor force from 2003 through 2013. We're going to use the regression feature of the graphing utility, where I can't spell, to find a linear model and a quadratic model for the data, and then determine which model is the better fit. So they want us to find a linear model and a quadratic model. So let's start with the linear model. So the first thing we need to do is we need to put in our data. Now here's the thing. The years are going to represent our X, right? Now you can put in 2003, 2004, 2005, 2006, blah, 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 which is probably what we're going to do. But you could also say, okay, well, this is 3 is going to represent my year, right? You would just have to adjust that when you were thinking later. So we'll go ahead and put these in because we can adjust our table and it's not that big of a deal, our window. All right, so we'll go ahead and do years. That's our X. And then the number of people is your Y values. So we'll go to Stat and go to Edit and clear out your data, or type over it, either one, and put that data in. Okay, now that we have our data in, we're going to have to adjust our window. So we've got 2004 is our smallest. No, 2003. So let's just start with 2000. And then 2013 is our highest, so maybe go to 2015. And counting by ones is fine. And then our smallest Y value is in the 70s. So we'll start with 70. And our biggest Y value is 90 something, so we'll go to a 95. Count by ones. And when you go to your Y goals, you should probably take this out because that's not going to be part of your data anymore, right? So I'm going to clear that out and go to my graph. So this one really kind of looks like it could be either, right? But we're going to figure out which one we think is better. So we're going to go to Stat and Calculate, and we're going to start with linear. So we're going to start with our linear regression, which is option 4. Go to Calculate. All right, so this has an R2 value of 0.96, which is pretty high, right? And we're going to write down that as our linear equation that they wanted us to come up with. So we have, we'll do 4 decimal places again. So 1.5527x and then the b is negative, so we'll say minus 3036.6673. 6673. And I'm just going to write the R2 value here. That way we can remember what it was. So it was 0.9608. All right, so now we'll do the quadratic and see how that fits. So we'll go back to stat, calculate, but this time we're going to calculate the quadratic regression, which is option 5. All right, this R2 value is bigger, correct? It's like closer to 1. So this one is actually probably going to be the better fit. But we're going to go ahead and write the equation for that, which would be 0.1068 x squared and then b is negative, so minus 427.1951 x, and then the c value is 427.425 0.0418, and the R2 value on this one was 0.99, right? So use the R2 value to decide. You could graph both of them and see which one looked better with your data, right? But that R2 value is going to tell you which one is better. So this is the better fit. So quadratic is the better fit. I'm just going to box that in so we know that was our answer.